All right, we're just going to use our normal index laws. Oh, my pen's not working, excuse me. We're going to just use normal index laws for these. Like, there's no trick. Even though we've got fractions and stuff like that, it doesn't matter. So for A, we're going to have x to the 2.5 plus 3.5, which is x to the 6. For C, well, we always multiply the numbers first. And then we've got x to the -2 plus 4. And we've got y to the 1 plus -2. And overall that gives me 15x to the 2, y to the -1. We're leaving it in index form so we don't put it as a fraction. E, this time we subtract. So we've got x to the -7 minus -2.5. -7 plus 2.5. Gives me x to the -4.5, which is x to the -9 on 2. G, brackets we multiply, so we've got x to the -2/3 times 6. -2/3 times 6 on 1 is -4. And I, this means we've got 9s to the -4t to the 5 to the 3 on 2, which means we've got 9 to the 3 on 2, s to the -4 times 3 on 2, t to the 5 times 3 on 2, which means we've got 9 to the half cubed. S, -4 times 3 on 2 gives me -8. No, -6, sorry. T to the 15 on 2. Now, 9 to the half is 3, because that's the square root of 9. Cubed, S to the -6, T to the 15 on 2. 3 cubed is 27. S to the -6, T to the 15 on 2. Wasn't too bad. Let's have a look at these ones. So, again, we're doing the same thing but with numbers. 2 to the half plus a half, 2 to the 1, which is 2. 2 to the half plus 2.5 gives me 2 to the 3, which is 8. 25 to the 1 minus a half gives me 25 to the half. Now 25 to the half is the square root of 25, so it's 5. 3 to the 3 plus 4 minus 10 gives me 3 to the -3, which is 1 on 3 to the 3, which is 1 on 27. And this one's 9 to the 8 times a quarter, so it's 9 to the 2, which is 81. None of those should have been very surprising. Let's have a look at question 6. Now, question 6, I'd like you to approach them by getting both sides to the same base. Now, when I'm looking at 9 and 3, the base is 3. Yeah. So this is the same as 3 squared to the x equals 3, yeah? So I have 3 to the 2x equals 3 to the 1. Actually, I'm going to write my working out down below. So I've got 9 to the x equals 3, which means I've got 3 squared to the x equals 3. So I've got 3 to the 2 times x, 2x, equals 3 to the 1. So 2x equals 3, equals 1. So x equals 1 on 2. Question C. What is C? 81 to the x equals 3. 81 to the x equals 3. Now the base for these ones is going to be 3. So 81 is 3 to the 4. To the x equals 3. 3 to the 4, so this is 3 to the 4 times x. So 4x equals 3 to the 1. 4x equals 1, x equals 1 on 4. Question E. Now this is the same as 1 on, so this is 1 on 25 to the x equals 1 on 5. Now this is the same as 25 to the minus 1 to the x equals 5 to the minus 1, which means I've got 5 squared to the minus 1 to the x, 5 to the minus 1. So this is 5 to the minus 2x, because you multiply all the powers to minus 1x. So we know minus 2x equals minus 1. So x equals negative 1 over negative 2, so a half. Okay, question 7. So this time we're going to want to go backwards. Normally we've been turning stuff into indices because they're easier to work with rather than keeping them as surds, but we're going to go backwards. So this is the same as the square root of x. So it's always the number on the bottom goes out the front of this. Now we don't usually write the 2, so it's just x, square root of x. Now this is the same as x, 7 times the square root of x. So we would write that as 7 root x. This is the same as 15 times the 4th root of x. So it's 15 4th root x. This is the same as 6 times x to the 5 to the half. Now this is the opposite way that you're used to thinking about it, which is fine. Which is the same as 6 times the square root of x to the 5. So we literally write 6 root x to the 5. Or you could have had 6 times x to the half to the 5, 6 times root x to the 5. I just want you to understand that this and this are the same, but this is how we prefer to write it. Alright, now we're doing it with some numbers involved. So, oh no, now we want fractional indices instead of surds. So root x is the same as x to the half, because it's a square root. If there's no number there, it's a square root. Now this is the same as 3x to the half, which is 3 to the half x to the half, although I'd be surprised if they wanted it in that form instead of like, yeah. So this is the same as 9 times x to the 1/6, so it's 9x to the 1/6. And this is the same as x to the 9 to the half, which is x to the 9 times a half. So it's x to the 9 on 2. It's always the number out here that goes on the bottom, and that's a 2 when there's nothing there. And it's always the number in here that goes on the top. Last one for this video, question 9. Rewrite each expression as a single power of x using fractional indices. Ooh, handy. This is a really good skill to have, by the way, to be able to do these. So this is the same as x squared times x to the half. This is a skill we're going to use a lot when we do differentiation later on. So this is the same as x to the 2 plus a half. So this is x to the 5 on 2. You can add the 2 plus a half, by the way, in your calculator. I want to write that 5 better because my 5s are always terrible. Always. Okay, for C, we've got x to the 3 times x to the 2 on 3, because remember, the number out the front goes on the bottom, and then this one just goes on the top. So that's x to the 3 plus 2/3, which means we've got x to the 11 on 3. That's it for this video.